In this video, we are going to discuss scientific notation. Scientific notation is a way to write really large or really small numbers in a much simpler form. If you have 1, 2, 6, 0, 0, 0, 0, 0, 0, 0, 0, 0. Let's say you have this, 126 billion. That's a lot of zeros. I mean, we put the little commas in to help us separate it. But if you just see something like this, it takes you a little bit to sort out what that number is. That's a lot of zeros. And so you'd have to look and say, all right, well, oops, no, that's only 2. Here's 3, there's another 3. Oh, okay, it's 137 billion. It takes up a lot of space, and it's easy to mistype. If you're hitting 0 on your calculator 9 times, and one of them you don't press enough, it's not visually obvious right away. So we don't want to be stuck in this. We want to write this more simply. This is where scientific notation comes in. The simplest way to describe scientific notation is that it is an unfinished math problem. What I mean by that, well, let's say I wanted to have the answer to my question be 126 billion. Well, what math problem would I need to accomplish that? I could have 1, 2, 6, 0, 0, 0, 0, 0, 0, 0, 0. I could have 12 billion 600 million, and I could multiply it by 10. That would give me 126 billion. Well, I could also have 1 billion 260 million. I could multiply that by 100. That would also equal the same amount. Right? The idea is I'm just shifting a decimal. Basically, every time I multiply by 10, I make this number 1 0 smaller. Well, there's a few other ways to write 100. If I have 10, that equals 10. But if I have 10 to the second power, that equals 100. Remember, exponents just say multiply that number by itself that many times. This is 10 times 10. 10 times 10 is 100. So we could take this to the extreme. I started with a number who had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 decimal places beyond the first number. So I could rewrite this as 1.26 times 10 to the 11. What this tells me to do is to take 1.26 and multiply it by 10, which would be 12.6, and then do it again. This was our first time, and then you'd multiply it by 10 a second time, 126. You'd multiply it by 10 a third time, and so on and so on and so on. Every time it would get bigger until it was 126 billion again. This is much smaller to write, though. Instead of all those zeros that's easy to mistake, add an extra, or drop one, there's basically no zeros here at all. Just 126 times 10 to the 11. This is the idea of scientific notation. This math problem, if I answer it, indeed gives me 126 billion. But I can just leave it as the unfinished math problem. Well, I could do 12.6 times 10 to the 10, or 126 times 10 to the 9, or 1,260 times 10 to the 8, and we can just kind of keep doing this for a while. 12,600 times 10 to the 7, all of these equal the same value. They all equal that 126 billion. So which one? what do we pick from this list? Why did I circle that one up above? Why do we want 1.26 times 10 to the 11? Scientific notation says of all your options, pick the option that has a single number in front of the decimal. So whatever number we have, we want to shift the decimal until only a single value is in front of it. Let's go with 356,000. Well, to start, my decimal is right there. If I move it once, twice, 3, 4, if I move it 5 times, I will get just the 3 in front of that decimal. So this will look like 3.56. And then I say, all right, well, I need to multiply it by 10 to get back to our original number. Well, every time I multiply by 10, it will shift back one decimal. So it would say, go here's times 10, it would be 35. Here's times another 10, it would be 356. I have to shift it 1, 2, 3, 4, 5 times. And so I need to multiply it by 10 5 times to get back to our original value. And so this is which one we pick for scientific notation. You want to move that decimal until it is one number in front of the decimal. So just the 3 was in front. If we have smaller values, say 0.0072, it's not that many zeros, but you can definitely have values that are 11, 12 zeros before a number. It gets unwieldy again. It's even harder than large numbers because we don't use commas to separate small numbers. Well, the idea is I want a math problem that will give me this answer. If I had 7.2, I could divide that by 10. That would go to 0.72, which I could then divide by 10 again to get 0.072, and I could divide by 10 again to get 0.072. If I divide by 10 enough times, I can turn my one number in front of the decimal value into the answer we want. So if I want to discuss 0.072 in scientific notation, well, I need to move that decimal once, twice, 3 times before I have a number in front of the decimal. So to take 7.2 backwards would require us going from 7.2 once, twice, 3 times to bring us back. But if I'm dividing by 10, well, there's a couple ways to write that. You could say 7.2 divided by 10 to the 3. The other way is 7.2 times 10 to the negative 3. Negative exponents tell you to divide those values that many times. And so when we had large numbers, our exponent was positive so that 3.56 would get bigger to return us to our 356,000. When we want small numbers, our negative exponent tells us to shift to the left to get smaller in order to take 7.2 back down to 0.072. So let's try a little practice. Turn this number into scientific notation. Give it a shot, take a minute, and then come on back. All right. Well, if we are trying to convert this into scientific notation, first thing is I go up front, I find my numbers that aren't 0, and I say, okay, I want only one of them in front. So I'm going to end up with 1.275. It's going to be times 10. And the idea is if I'd had my decimal here, I'd need to move it once, 2, 3, 4, 5. I'd need to move it 6 times to get back our original value, our 1,275,000. So I need to multiply it by 10 6 times. As to our smaller value here, well, go find my numbers aren't 0, 3 and 4, so it's going to be 3.4. This gives us one number in front of the decimal. We times 10 to some negative value. The idea is how many times would I need to move a decimal from 3.4 to get us back to where we want, to our 00034. So that would be 1, 2, 3, 4, has to move 5 times. So 10 to the minus 5. Let's try another one. 7.82 times 10 to the 4. And 6.87 times 10 to the minus 3. Try to convert those into their full numbers. All right. Well, I have 7.82, and I'm going to make it bigger. Multiply by 10 4 times. So first multiply by 10 will give me 78. Second will be 782. 3 and then 4. Fill in zeros to that decimal. 78,200. My 6.87 I'm going to divide by 10 3 times. So the first time, the second, and the third. Fill in zeros here. We're going to find that it is 0.00687. So there's a few examples of scientific notation on how to convert a number into scientific notation and how to convert a scientific notation value into the number.